Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to talk about making up your own tests compared to design of experiments. And in particular, I'm going to take a look at a little case study. Somebody sent me a DOE, they sent me an experiment, I should say. They made their own pattern up. I analysed it and gave them some advice. So we're going to take a look at that little problem in a moment. Before we get on to that, of course, just a reminder, drink tea and read the paper. All of my videos are based on this book that I wrote about a year ago. It's on sale on lulu.com, drink tea and read the paper. You can also get an electronic version. So if you like the videos and you want to learn more, it's all in this book. Please go and buy it. Now let's take a look at this little case study. So DOE versus, I'm going to call this one factor tests, because this is often what people do if they don't use a designed experiment. Now the designed experiment, the special pattern, it's a special pattern. It is a balanced pattern. Now people tend not to use this. Often they haven't been taught it. But if they're going to do a deliberate engineered test, they typically go for a one-factor test. So what will a one-factor test look like? Well, if we've got three variables, A, B and C, if we start with them all at a single level, so we'll call it level 1, what they'll then do is they'll make a one variable change. So what they'll typically do is they'll change A to 2, leave the other two where they are, and of course each time we're getting results here. So we'll set the pattern up as everything at the low, then we'll get a result, then we'll change A to 2 and we'll get a new result, and of course we'll analyse what's happened and we'll try and suggest A created that pattern change or created that difference in the results. Then what they'll do, of course, is they might continue with that at 2, move B to 2. So only changing one factor at a time. Then we get a new result. We compare those two. We say, B created that. And then finally, we move C to level 2. We get a result and we say the difference between those. C created that. Now, this is obviously a very simple example, but the example I'm going to show you now, the engineer who sent me this pattern, it's actually a mixture design, so that it's a percent. So each number you see on this table that I'm about to show you, these are percents that they're going to do. So it's making a mixture. It's like making a liquid. It isn't quite a liquid, but you'd understand it if we said we're going to put 25% of this liquid, we're going to put 15% of this, and of course it's got to add up to 100% when we finish the liquid. Now, in the particular example, first of all, we had 7 variables, and we're at multiple levels. So I think we're at 0%, we're at 1%. I think it goes to 20% at one point. It goes to 25%. So you can see from the pattern. If you look at the table here, you can see all the different variables. You can see the 7 variables, and you can see the different levels. Sometimes the variable's at 0, like in this area here. Sometimes the variable has been moved to 1%, etc., etc. Now in total, there's 126 tests. So that's what they sent me. Now what I did, the first thing I did was to test whether the pattern was going to give you the truth or not. Whether the pattern was was well designed. So what I quickly did was I put the data into my software. I filled the pattern, I filled the data table over on the right hand side here. You can see the yellow data table. I filled it with random numbers, which is what my software allows me to do. And then what I did was I pressed regression. Now the actual numbers from the regression don't matter, because what I was trying to get the software to do for me was calculate something called the tolerance. Now tolerances, when you do a balanced pattern, tolerances will equal 1. What that means is any signal you see from a particular analysis, so if you see a signal coming from variable A, what it's telling you is that's 100% clean and 100% of it is coming from A. If the tolerance gets degraded away from 1, what it's telling you is all of that signal is not coming from A, it's coming from somewhere else in the pattern, because you've mixed the pattern up in such a way that the data is no longer clean. Now if you look at my tolerances here, look, if you click on one of these boxes here for the tolerance, now this is as close to 0 as you can get without being 0. It's actually saying 799 to the power 15, so you can see that it's got 15 noughts in front of it. So it's as far away from 100% as it could possibly be. And what this is telling me is this pattern, which is effectively a one-factor test, it's a test that is made up, is going to create poor data. It's going to create spurious results, and it's not going to work for him. So what I've done, I've sent him a pattern that is balanced, that does have tolerances of 1, where the variables are not linked to one another, and therefore they are multiplying their effects, or they are cancelling each other's effect out. And that's what happens in one-factor tests. So that's the difference between a DOE and a one-factor test. What the DOE is going to do, typically, it's going to give you more information. It's going to give you better information. And typically, it will do it faster, often, with a smaller sample size. So typically it's more information, it's cleaner information, it's going to be the truth, and it's going to come at you faster. DOE is the fastest way to find out. It is the fastest way to take new technology and make the most amount of money out of it in the fastest possible time. Now if you like this video, please give it a thumbs up, click on like to beat the Google algorithm. If you've got any comments and you want to ask any questions, please drop some comments below, because that helps with the channel as well. Be great to hear from you. I'd love to help you anytime to make more money, because DOE, that's what it does. It helps you to make more money.